Hello everyone, I am Dr. Sonia Juneja, Assistant Professor in Kite Group of Institutions, Ghaziabad. Today I am going to start electromagnetic theory, which includes introduction, laws of electromagnetics before Maxwell's, equation of continuity, then concept of displacement current with some numerical examples. We know that static electric and magnetic fields in electrostatics and magnetostatics are produced by charges which are at rest. Therefore, these electric and magnetic fields can be analyzed independently. Means electric and magnetic fields in electrostatics and magnetostatics are produced by rest charges. Therefore, they can be easily analyzed independently. But when the electric and magnetic field varies with time, then the independent analysis are not possible. Because Faraday's law of electromagnetic induction says that a time varying magnetic field produces electric field, and Ampere law says that a time varying electric field produces magnetic field. Means according to Faraday's law, when the magnetic field changes with time, it produces electric field, and Ampere's law says that when the electric field changes with time, it produces magnetic field. Both time varying electric and magnetic fields coupled with each other and produces a special kind of field which is known as electromagnetic field. Hence, electromagnetic field consists of electric field and magnetic field. Both fields are changing with time. Electric field changing with time and produces magnetic field, and magnetic field changing with time and produces electric field. Both fields are coupled with each other and produces electromagnetic field. Now, laws of electromagnetics before Maxwell's. There are basically 4 laws before Maxwell's. First law is Gauss law of electrostatics. Gauss law of electrostatics says that the electric flux through any closed surface is equal to 1 by epsilon naught times of total charge enclosed with it. Means surface integration of E dot ds, which shows electric flux is surface integration of E dot ds. It should be equal to, according to Gauss law, Q by epsilon naught, where epsilon naught is the free space permittivity and Q is the total charge enclosed within the surface. Where E dot ds, again surface integration of E dot ds is known as electric flux. It should be equal to, according to Gauss law of electrostatics, Q by epsilon naught. Next law is Gauss law of magnetostatics, which states that the net magnetic flux through any closed surface is 0. The magnetic flux surface integration of B dot ds is equal to 0, which indicates that monopole cannot exist. If we take a small part of magnet, it includes north and south poles. Magnetic field lines makes closed loops. Therefore, the net magnetic flux surface integration B dot ds should be equal to 0. So, Gauss law of magnetostatics says that surface integration of B dot ds is equal to 0. That is, monopole cannot exist. Third law is Faraday's laws of electromagnetic induction, which states that the closed line integral of induced electric field to the negative time derivative of enclosed magnetic flux means change in magnetic flux produces electric field. That means line integral of E dot dl is equal to minus del by del t of phi b, where phi b is known as magnetic flux, which is equal to surface integration of B dot ds, and line integral of E dot dl is known as electromotive force. Then change in magnetic flux phi b, when phi b changes with time, change in magnetic flux with time, it produces electric field or electromotive force. Then Faraday's laws of induction, line integral of E dot dl, which shows electromotive force, it should be equals to minus del phi b by del t. Fourth law is Ampere's law. Ampere's law says that the magnetic field around a closed path is equal to the total current flowing through any surface bounded by that path. Means line integral of B dot dl is equal to mu naught I, or line integral of H dot dl, which is known as magnetomotive force, is equal to I. Means where the magnetomotive force is equal to I. When the current flowing in the conductor, it produces the magnetic field. This is the Ampere's law. Now, equation of continuity. Equation of continuity based on the principle of conservation of charge, which says that electric charges can neither be created nor be destroyed. Electric charges can neither be created nor be destroyed. Therefore, equation of continuity states that the current flowing out of some volume is equal to the rate of decrease of charge within the volume. Again, the statement of equation of continuity is the current flowing out of some volume is equal to the rate of decrease of charge within the volume. To prove equation of continuity, let us consider a volume V bounded by a closed surface S. If ds is the surface element, then the conduction current I or IC, which is due to the flow of charges, is equal to minus dq by dt. Conduction current I or IC is equal to minus dq by dt. If J is the current density, then I is equal to surface integration of J dot ds, where J is the current density. Current density is equal to current per unit area. Then the total current is equal to current density into area. If we find the total current, then the integration, surface integration of J dot ds denotes the total current I. Similarly, if rho is the volume charge density, then the total charge enclosed with it, Q is equal to volume integration of rho dV, where dV is the volume element, rho is the volume charge density, then the total charge will be obtained by volume integration of rho dV. Substituting the value of current and charge in conduction current equation, I or IC is equal to minus dq by dt, we have surface integration of J dot ds, which is equal to minus d by dt of volume integration of rho dV. Then surface integration of J dot ds is equal to minus volume integration of del rho by del t into dV. Applying Gauss divergence theorem on the LHS of this equation, LHS means left hand side of this equation, then this surface integration converted into volume integration. Then the equation becomes volume integration of divergence of J into dV is equal to minus volume integration of del rho by del t into dV. Then volume integration of divergence J plus del rho by del t into dV is equal to 0. dV can't be 0. This is the volume element. Therefore, divergence J is equal to minus del rho by del t, which is known as equation of continuity. This expression divergence J is equal to minus del rho by del t is known as equation of continuity, which says that if charge is moving out of some volume, means divergence of current density is positive, means divergence of J, then the amount of charge within that volume is going to decrease, means minus del rho by del t. The rate of change of charge density is negative. Then the equation of continuity, the current out of some volume, the current flowing out of some volume means divergence of J is when the current out of some volume is equal to the rate of decrease of charge in the volume, means divergence of J is equal to minus del rho by del t. This is the equation of continuity. Next is concept of displacement current. The concept of displacement current ID was first introduced by Maxwell. According to him, not only current in a conductor produces the magnetic field, even changing electric field in vacuum or in a dielectric also produces the magnetic field. To explain the concept of displacement current, Maxwell considered a series circuit which is shown in diagram. This is a series circuit having resistance, capacitor, battery, battery, etc. When when the current is flowing, then the conduction current IC is same for all cross section in this series circuit. The conduction current IC is due to the flow of charges, which is same. We know that conduction current IC is same in a series circuit. According after passing the resistance, IC will be same. After passing the capacitor, IC will be same. But how? Capacitor is an arrangement of two metallic plates between between dielectric is filled or vacuum is filled. There is no sources of motion, no source of conduction. This is the two metallic plate having a gap or having a dielectric. Then the current should be not IC. But how IC enters in the capacitor and leaving the current should be IC? There should be the discontinuity in conduction current IC when it passes through the capacitor. But when the Maxwell put the compass needle at the capacitor plates or between the capacitor plates, it deflects. It means the magnetic field is present between the plates of the capacitor. Means that there must be a source of magnetic field. There must be a source of magnetic field between the plates of a capacitor. Then Maxwell says that changing this source is nothing. It is changing electric field, which arises due to the charge transfer from one plate to another plate of the capacitor. Means changing electric field is equivalent to a current and give the same effect as magnetic field as the conduction current. This equivalent current is known as displacement current, ID, which arises due to changing electric field. Means changing electric field produces magnetic field. This means changing electric field here, a source of magnetic field. Changing electric field is equivalent to a current which is known as displacement current, which exists in space as long as electric field is changing. For this, let us consider a parallel plate capacitor. We know that conduction current IC, which is due to the flow of charges, is equal to dq by dt. If d is the electric displacement vector, then d is equal to q by a. Then q is equal to dA. Then the conduction current IC becomes a dd by dt. Means IC is equal to a dd by dt. Then the Maxwell suggested that this conduction current should be equal to the displacement current, because the numeric value of displacement current should be equal to the numeric value of conduction current. Then ID becomes a dd by dt. Then the displacement current density JD is equal to ID by A, which is equal to dd by dt. In the vector notation, JD is equal to dd by dt, where JD is the vector, D is the electric displacement vector. If D is equal to epsilon naught E, where epsilon naught is the free space permittivity, then JD becomes epsilon naught dE by dt, where JD is the displacement current density. Therefore, the current arising due to the time varying electric field between the plates of the capacitor is called displacement current. Hence, displacement current arises due to changing electric field between the plates of the capacitor. This is the concept of displacement current. These are few numerical examples. For a medium, conductivity sigma is equal to 58 into 10 to the power 6 Siemens per meter. Epsilon r is equal to 1. Find out the conduction and displacement current densities if magnitude of electric field intensity is given by E is equal to 150 sine 10 to the power 10 t volt per meter. Then we have sigma, conductivity, electric field, and relative permittivity. Then we know that the conduction current is due to the flow of charges. Then from the Ohm's law, Jc is equal to sigma E. Substituting the value of sigma and E, we get the conduction current density Jc is equal to 8.7 into 10 to the power 9 sine 10 to the power 10 t ampere per meter square. Now the displacement current density, from the previous article we know that Jd is equal to dt by dt. For the medium, it is equal to epsilon dE by dt. It is not equal to epsilon naught dE by dt because it's a medium. It is equal to epsilon dE by dt. And epsilon is equal to epsilon naught into epsilon r. Epsilon naught is equal to 8.85 into 10 to the power minus 12, which is known as free space permittivity. And epsilon r is equal to 1 given problem. And substituting the value of V, we get the displacement current density is equal to 13.28 cos 10 to the power 10 t ampere per meter square. Next example is find out the current density and electric intensity for aluminium conductor having conductivity sigma is equal to 3.82 into 10 to the power 7 Siemens per meter and electron mobility mu is equal to 0.014 meter square per volt per second. And drift velocity 5.3 into 10 to the power minus 4 meter per second. Now we have conductivity, mobility and drift velocity. We know that mobility is defined drift velocity per unit electric field. From this expression we can find electric field is equal to Vd by mu e. Substituting the value of Vd and mu e, we have electric field 0.3786 volt per meter. And the conduction current density, if we find the value of electric field E, then we can easily find the conduction current density from the Ohm's law. Jc is equal to sigma E. Then Jc becomes 1.446 into 10 to the power 7 ampere per meter square. If you have any problem regarding this lecture, kindly email me on sonia.juneja@kiet.edu. Please mail me sonia@kite.edu. sonia.juneja@kite.edu. Thank you.